Algebra 2, target 26. I can sketch the graph of any exponential or logarithmic function. Keyword here being any. Okay, as we saw in target 25, we learned how to graph very basic exponential and logarithmic functions. Okay, now we're going to look at translations, okay, of those same functions. In this first part of target 26, we will be focusing on translations of just exponential functions. And in the second part, we will look at logarithmic functions, translations of those. All right, so what is a translation, first of all? Okay, so to graph a function of the form y equals a times b to the x minus h plus k, we want to begin by sketching the graph of our basic function, y equals a times b to the x, and then translate the graph horizontally h units and vertically k units. So essentially all we're doing is we're taking the points that we had in our basic exponential functions and we are adding h to all the x coordinates. Okay, so we're taking all the x and adding h to it, and we're taking all of our y's and adding k to them. All right, so how does this change our graph? Okay, well, again, with the points, right, we take our original points of negative 1a over b, 0a, and 1ab, and then we add h to all of the x coordinates, and we add k to all of the y coordinates. The other change is to our asymptote. Okay, the asymptote is no longer going to be the x-axis, it's going to be the horizontal line y equals k. All right, so let's start with an example of how this works. So the first thing I'm going to do when I graph is I'm going to identify what is A, what is B, what is H, and what is K. Now, if we go back to this, one thing that we have to be very careful of, okay, is that this is x minus h. Okay, so make a note, right? H is subtracted from x. Right, what that means is when we see it in the actual equation, h is always going to have the opposite sign of what's shown. So if I see x minus 1, that means that h is equal to positive 1. If I see x plus 1, then that means that h is equal to negative 1. Okay, because it's what's subtracted from x. All right, so going back to our first example, y equals 4 times 2 to the x minus 1 minus 3. So there's 4 numbers here. Okay, each one of them represents one of our values. So the 4 here is A, the 2 is going to be B, the 1 is going to be H, and the negative 3 will be K. So the first thing I want to do is set up my points that I'm going to plot. So my normal 3 x coordinates are negative 1, 0, and 1, but I want to add h to each one of them. So I'm going to take negative 1 plus 1, I want to take 0 plus 1, and I want to take 1 plus 1. All right, then for the y coordinates, I'm going to take a divided by b, so 4 divided by 2, plus k, so minus 3. Then I'm going to take a plus k, so 4 minus 3. And then my third y coordinate is going to be a times b, so 4 times 2 plus k, so minus 3. So if we simplify those, our x's and y's are now 0, 1, and 2, and the y coordinates are 2 minus 3, so that's negative 1, 4 minus 3 is 1, and 8 minus 3 is 5. So those are the points I'm going to plot, and my asymptote, the other thing I need here, is going to be the horizontal line y equals k, which is -3. All right, so now I'm set up to draw the graph. So first I'm going to draw this asymptote. So at y equals -3, so go down 3 and draw a horizontal line. And we'll just make it dashed. Again, this doesn't have to be exact, it just has to give us an idea of the line that we're not going to cross. Then we plot the 3 points. So 0, -1 is here, 1, 1 is here, and 2, 5 is here. And now we're ready to draw our graph. So we're going to start along the asymptote on this side and curve up through those 3 points, making our J-shaped curve, just like before. All right, a next example, y equals 5 times 2/3 to the x plus 3 minus 2. So here are values. We have 5, that's going to be A. We have 2/3, that's B. Okay, we have plus 3, that means our H is going to be -3. And then we have -2 for our value of K. So our points that we're going to plot, our normal x values were -1, 0, and 1. So we're going to add H to each one of those. So it'll be -1 minus 3, 0 minus 3, and 1 minus 3. And then our k values, a divided by b, so 5 divided by 2/3, plus k, so -2. Then a plus k, so -2. And then a times b, so 5 times 2/3, plus k, so -2. So simplifying those, our x-coordinates are -4, -3, and -2. And our y-coordinates, if we do 5 divided by 2/3, that's 5 times 3/2. So that's 7.5, minus 2 is 5.5. 5 minus 2 is 3, and 5 times 2/3 is 10/3, so 3 1/3 minus 2 is 1 1/3. And our asymptote is going to be the horizontal line y equals k, which is -2. So to draw the graph, start with your asymptote, horizontal line here at -2, and then plot those 3 points, -4, 5.5 would be here, -3, 3 is going to be here, and -2, 1 1/3 would be here. Right. So our graph will come along the asymptote on this side and then curve up through those 3 points. And one more example. This time we're going to have a natural base. So in this case, it's 1 times this. So your A is 1. Your B is this, e to the -0.75. H is here as 2, and k is your +1. All right, now if we calculate e to the -0.75, we see that that is equal to about 0.47. So that's what we're going to use for our B. So when we figure out our points that we're going to plot, we have x and y. Again, our normal x values are -1, 0, and 1. But we're going to add h to those, so add 2, so -1 plus 2 0 plus 2, and 1 plus 2. And our y coordinates, a divided by b, so 1 divided by 0.47 plus k, so plus 1. Then a plus k, so 1 plus 1. And lastly, a times b, so just negative 0.47 plus 1 plus your k. So those values, negative 1 plus 2 is going to be 1, 0 plus 2 is 2, 1 plus 2 is 3. Okay, 1 divided by 0.47, let's calculate that. 1 divided by 0.47 is about 2.1. So 2.1 plus 1 is about 3.1. 1 plus 1 is 2 here, and then about 1.5. Again, if we're graphing, we don't really need to go to the hundredth. Just one decimal place is okay. And then our asymptote will be y equals k, which is 1. So our graph, do the asymptote first. So that's y equals 1, which is right here. Then plotting the points. Got 1, 3.1, which would be right about here. Then 2, 2 would be here, and 3, 1.5 would be about here. So our graph is going to go along the asymptote on this side, and then curve up through those points. All right, so those are some examples of graphing exponential functions, okay, that are translated. Okay, they're slid, okay, from the normal spots. So a quick summary, okay, steps for graphing an exponential function. Identify the values of a, b, h, and k. Be very careful with h. Okay, so be careful there. Identify your asymptote, which is just y equals k, and then plot your 3 points where you're adding h to all the x's, and you're adding k to all the y's, and then finally draw your J-shaped curve. All right, so that'll do it for the first part of Target 26. Okay, second part is looking at drawing graphs of logarithmic functions. So we'll see you then.